Okay, let's have a look at another example. Now, obviously, it says find the value of the pronumeral, correct to one decimal place. Obviously, here's the pronumeral. Things to observe are the triangle is non-right angled. The side we're finding is opposite an angle. It's always good. And in fact, we would say all three sides are involved in this triangle because we're given the length of 2 and we're being asked to find the third. So all three sides are involved and an angle is also given. That hopefully clearly identifies the cosine rule as the way to answer this question. So you can see now I've written the cosine rule for finding a side. Now, I think that this is a really important step. Because we write the rule in this format, then name the side lowercase c. Hopefully that will automatically enable you to have the angle it's opposite as angle C, and then the position of the other two sides. It doesn't really matter. This is really, I guess, even more important when we're finding an angle, and we'll see that in the next example. So going to the calculator, provided I've put that all in correctly, 5 squared, 8 squared, 2 times 5 times cos C. $46.38. Whoops. And equals again 5.838. We'd be happy with that answer. It's in the ballpark of the other two sides, a 5 and an 8. That's probably about all I need to say about that. Let's have a look at this second example. Evaluate the pronumeral, correct to the nearest minute. So clearly it's going to be an angle, and as you can see it is. Now, what I was saying before was it's really important that we get these sides, all three sides are involved, one angle. It's really important that we identify, in this case, that the angle is going to be C, because remember when we write our formula for finding the angle, its angle C is the cos inverse of a squared plus b squared minus c squared. Now, if you don't get these numbers in the correct spot, the length of the sides in the correct spot, obviously, in this fraction, well, obviously you're working with the incorrect fraction, which might, well, most commonly it gives you an error when you try to do this on your calculator, or otherwise it just gives you the wrong answer. And it's all over 2 times a times b. So, knowing that we've labelled the C, the importance of getting this as your C is really important. So these can be A and B. And you can see there most of my calculation, and it came up as a decimal, obviously, at first. I pressed the DMS button, and it's going to angle C is going to be 60 degrees, 27 minutes, 20 seconds. We can ignore it, has no impact on the 27. So it's 60, 27, 60 degrees, 27 minutes. That was to the nearest minute. Now, there is no issue with theta doesn't look obtuse here, and nor did it come up obtuse. You can't always be sure the diagrams are drawn to scale. There might be times when it's very inaccurate in its drawing, and theta could be obtuse without the diagram looking like it. You could end up with theta getting the value out of the calculator, and it's obviously obtuse. The good thing is the calculator will tell you. The calculator, if this, based on the value of that calculation in the brackets there, in that fraction, the calculator will take into account if it needs to give you a negative answer. So that's really nice. If you didn't get started after the sine and cosine rule videos, the sine and area of triangle videos, you'll need to get started now on H and I.